Hey everyone, welcome to another video about the unit circle. In this video, you'll learn how the coordinates of the angles on the unit circle are obtained. We'll apply principles from right triangle trigonometry and basic geometry to justify our conclusions. Let's get started. So here's the unit circle, radius 1, centered at the origin. Because it has a radius of 1, at 0 degrees, we would have the coordinates 1, 0. Makes sense, it's gone 1 unit to the right and neither up nor down. At 90 degrees, 0, 1, it's gone 1 unit up. At 180 degrees, negative 1, 0, because it's gone 1 unit to the left. 270 degrees would be 1 unit down, so 0, negative 1. And then we come full circle at 360, so we're back to 1, 0. These are called the quadrantal angles. And in radians, we've got 0, pi over 2, pi, 3 pi over 2, and 2 pi. So let's look at the coordinates for a 45-degree angle. Now I'm reminding you here that the radius of the unit circle is 1, and we want to know what the coordinates are right here. Without actually typing them into our calculator, we want to know the exact value. So if you'll just bear with me here, I'm going to take what I've sketched before, and I'm just going to reflect that radius in the x-axis so that again I have another 45-degree angle. And I'll drop the vertical so as to create a triangle. Now there's something special about this triangle. It's a 90-degree or right triangle, right? So 45, 45 is 90, so I've got a 90-degree triangle there with lengths, shorter lengths, 1 each. Okay, so let's call the unknown side or the hypotenuse C, and as you know, you can use Pythagorean theorem to determine the length of that hypotenuse, and it turns out to be root 2. So knowing that that's root 2, we can divide our 90-degree angle into two 45s again. We can divide our root 2 into two equal parts, root 2 over 2, and therefore we end up with the dimensions of this right triangle. Now, I say dimensions, but we have 2 dimensions, so we are still missing 1 dimension. But if it's a 45, 90-degree triangle, the other angle must be 45 as well. And if these two are 45, then the base length and the height must be equal as well. So therefore we know that the base length is also root 2 over 2. Okay, so now we have the base and the height, which then should give us the coordinates root 2 over 2 comma root 2 over 2. And so we've determined, or we've justified the coordinates as exact values at 45 degrees. Okay, so I'll simplify that. We can take this reflected across the y-axis into quadrant 2, and at 135 degrees we'd also have root 2 over 2 comma root 2 over 2, except of course the x-coordinate would be negative because we're in quadrant 2. Both coordinates would be negative in quadrant 3, but they remain root 2 over 2. And same thing in quadrant 4 at 315 degrees. It's again root 2 over 2 comma root 2 over 2 with a negative on the y-coordinate this time. Okay, so in one fell swoop, what we've done in quadrant 1 can be applied to the other quadrants, and we've got 4 sets of coordinates already. Okay, and again, we'll show you this in radians. And now we move on to 30 degrees. What are the coordinates on the unit circle where the terminal arm of 30 degrees intersects the unit circle? Okay, so again, I'm going to do kind of the same thing here. So I'll reflect the radius that I've drawn at 30 degrees across the x-axis. This time I unfortunately do not get a right triangle, but something interesting happens. So I'll drop the vertical to create this triangle. Now here's the thing. I know that if this is 30 degrees in a right triangle and this is 90, then of course to add up to 180 this would also have to be, the other angle would have to be 60 degrees. Okay, and since this is a reflected triangle, you know, this lower triangle is a reflection of this upper triangle, then this angle here would also have to be 60 degrees. Now the 30 and the 30, and I'll show you that again, the 30 and 30 add up to 60, so now I've got a triangle where all 3 angles are 60 degrees, and so that's known as an equilateral triangle. So if it's equilateral, then I guess the third side is also equal to 1. Okay, so what can we do with that? Well, if the third side is equal to 1, then, and we have a reflection of this right triangle across the x-axis, then I can just split that 1 into 2 equal parts. So the heights of each of those triangles in those quadrants is equal to half. Interesting. So I'll render that back to 30 degrees. I'll get rid of the bottom triangle, And again, I have a situation where I'm not aware of what the base is. Okay, so going to Pythagorean theorem, x squared plus the height squared is equal to 1. Half squared is a quarter, and 1 minus a quarter is 3/4, so square root x turns out to be root 3 over 2. So again, I can take the dimensions of this triangle and render them as coordinates. The x coordinate is the base, the y coordinate is the height. Okay, so I'll clean that up. So at 30 degrees, root 3 over 2 comma half are the coordinates. I'll reflect that across the y-axis and get similar coordinates with the negative on the x coordinate. Flip it into the third quadrant, so at 210 degrees, we've got negative root 3 over 2, negative half. And flip it once more across the x-axis to 330 degrees to get root 3 over 2 comma negative half. And in radians, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay? All right, and finally moving on to 60 degrees. Now the interesting thing about 60 degrees, I'm going to approach it this way. I'll drop the vertical right away. Now with a 60-degree right triangle, I know that the other angle is 30 degrees. Okay? And so this looks familiar. I've seen this before. Okay, I saw this a few slides ago where I had a 30-degree angle and then the other one was 60. So I've already seen a 30, 60, 90-degree triangle, and the dimensions were 1, root 3 over 2, and half. This is the same triangle, it's just oriented with a reference angle of 60, but I can easily put the corresponding dimensions on this triangle. Okay, so that's pretty straightforward. Now I've got the base and the height at half comma root 3 over 2. I'll clean that up, call this 60 degrees, flip it across the y-axis, and I get negative half comma root 3 over 2, flip it across the y-axis, flip it across the x-axis this time, before it was the y-axis, and flip it one more time. And again, it's just different variations of the same coordinates in exactly the same order, just the negatives on the different coordinates. Okay, and here we have the radian version. Okay, and so we've come to an end almost here, so I'm just going to summarize. So the left unit circle has the coordinates at those angles with a reference angle of pi over 3. And the unit circle on the right has those coordinates for angles with a reference angle of pi over 6. Okay, and then from earlier in this video, we of course had the quadrantal angles, and as well as the angles with a reference angle of pi over 4. Okay, and when you put all of this together, okay, you get these colorful unit circles. Okay, I didn't want to make it too messy and just create one, but so I just separated the radians and the angles of the unit circle from the coordinates. Okay, and that's the end of this video.